Okay, good afternoon. Nadidinig ba? Hello? Nakikita yung screen?
Yes po, sir.
Okay. So, let's continue our lesson. Okay, so this will be our transmission line and antenna. So this will be the calculation for transmission line and antenna. And because yung ating fiber optics ay nauna kaysa dito. So this will be also included to your examination. So all of the basic calculation of the antenna will be discussed today. Okay, so let's continue our discussion. So in order to radiate electromagnetic waves, so antenna are used. So alam naman natin yung that the antenna is an example of a transducer that able to convert one form of energy to another. So meaning to say the antenna radiates or converts the electric signal into a electromagnetic wave and electromagnetic wave into a electric signals. So the transmission reception of the signal requires this form of transducer. So as I discussed, it converts electric signal into electromagnetic waves and vice versa. And we all know that the electromagnetic waves comprises of two vector or two component, the electric field and the magnetic field vector. And on this particular module, the student will able to understand and calculate different antenna parameters and characteristics. So basically, we're going to discuss today are the calculations for the antenna parameters. So maraming calculations involved. But basically, yung ganitong calculation, you must have to learn it in preparation to your board examination. Sagot mo. So, yung isang isa-share. Okay, so let's solve the following sample problems about the antenna parameter characteristics and calculation. Okay, so number one, calculate the gain of a certain antenna relative to dipole antenna with a gain of 5.3 dB with respect to isotropic. So also compute the power gain if the antenna has the efficiency of 95%. So meaning to say, we need to calculate a certain antenna gain given yung gain of a antenna relative to isotropic. Okay, so in order to solve this, we're going to note the particular formula so that the gain in dB of a dipole antenna is equals to gain of a reference isotropic antenna minus 2.14. So this is a formula in order to get the gain of a dipole represented by your D from a isotropic antenna. So as we all know that the antenna gain with respect to isotropic is a reference antenna gain. So binigay naman dito yung gain with respect to isotropic. So meaning This is the DBI gain. Kasi sabi dyan, calculate the gain of a certain antenna relative to dipole, so that is the unknown DBD, with respect to a gain of 5.3 dB with respect to isotropic. And there is an efficiency of 95%. So out of this particular formula, so we can get the value of the antenna, DBD, that is equals to 5.3 dB. So you have here 5.3 minus 2.14. So what is your antenna gain with respect to dipole antenna? What is 5.3 minus 2.14?
3.16.
Ilan? 5.3 minus 2.14.
Yes po, 3.16 po.
Ha?
3.16 po.
Ilan? Again, hindi ko madinig.
Ay, sorry po.
3.16. Ha?
Yes po. 16 po, 1.6.
Are you sure? 3.16. Oo, yun nga pala yung sagot. Sure na sure, sir. Okay, that is 3.16. So since sabi niya man, gain of a dipole, DBD is equals to 3.16. So that will be your answer. Now, sinabi dyan, also compute the power gain of the antenna. It has the efficiency of 95%. The power gain. Okay, so that I will also note that the power gain is equals to efficiency multiplied by the directive gain. Okay, diba? So yun yung ating compute. Yun. So, but you need to get the value of your power gain, that is 95%. So, the gain, so pwede natin sabihin that that 3.16 dB, you need to convert into a unit less para magamit ito. Kasi kapag naka dB siya, hindi niyo magagamit yung formula na G efficiency times directive gain. So, convert muna the 3.16 into a unit less by, meron tayong formula 3.16 10 log of the gain. Kailan siya? Compute. So your gain is equals to inverse log of 3.16 divided ilan ng gain mo. Hindi ba ako? Of 3.16 divided 10.
2.07.
Ilan?
2.07.
2.07.
07.
Okay, so the gain therefore is 0.95 D. So the directive gain therefore will be 2.07 divided 2.07 divide 0.95. Hello, may kasi ako. Ha? Ano? Be positive. Be positive. Be positive. Okay, so ilan? Ano na ko yung sagot? So, this, since ang formula natin dito will be efficiency times D. So, the gain is actually efficiency times yung directed gain. So, itong kinuha natin dito, since binigyan na nga pala yung isotropic radiator, so that is definitely the directive gain. So, kaya, instead na ito ay G, this is actually your D. Okay? So, kaya kung 2.07, 95% of that will be 0.95 of 2.07. 0.95 of 2.07. So what is 0.95 of 2.07? Hello?
$1.97.
1.97. $1.97. Okay, so ang tinatanong dito is compute the power gain in dB. So you need to convert GdB, which equals to 10 log of 1.97. So ilan yun? Ten log of 1.97.
2.94.
Pakilakasan. Ilan?
2.94.
Okay, are you sure na 2.07 ito? Inverse law nga ng 0.316.
Ako sir, 2.07.
Ha?
2.07. Dala yung best leg ng 0.316.
Hindi ko kayo madinig.
First log po ng 0.316, 2.07.
Again?
Yung inverse log po ng 0.316 is 2.07.
2.07, correct. How about 0.95 of 2.07? Is it 1.97?
Opo, sir.
Yes.
Okay, so sige, yan ang nakuha eh. So ilan yan yung final answer? What is 10 log of
2.9
1.97? 2 point?
94.
Ay, tama na pala yung sagot, 2.94.
Opo, DB po.
Okay, so ayan. Tama naman pala. Kasi akala ko 2 lang yung sinasabi nyo. So the answer is 2.94 dB, which is, yun nga yung sa sagot natin. Okay, so nakuha ba yung number 1? So take note the following formula that the gain with respect to the dipole antenna is equals to dBi isotropic gain minus 2.14. 2.14 here is the constant. And we all know from the previous discussion that the power gain is equal to directive gain for a 100% efficiency. But if the efficiency is not 100%, so the gain is equals to efficiency times T, or the directive gain. Okay, so the answer for this is equals to 2.94 dB and 3.16 dBd. Okay, next. So calculate the radiation resistance of a halfway dipole if at the feed point is 2.25 meter from the end at 300 kilohertz. Okay, so pag sinabi nating feed point, so let's say for example, you have here a dipole. Yan. So yung sukat natin dito is lambda over 2. And now, meron daw siya, ang feed point natin ito, no? Kung saan natin ilalagay yung antenna, dito yung ating feed point. So meron siyang D, ang distance from the feed point is 0.25 meter. Okay, so the frequency is given as 300 megahertz. So, calculate the radiation resistance. If given yung dipole, so note another formula that the radiation resistance, R rad, is equals to 75 all over sine square. So, tandaan yung formula na to. So, kasi hindi ko ito nabigay nung nakaraan. So, that will be sine square of pi d over lambda. Pi d over lambda. So, where d is the distance of your dipole from the feed point. Now, kung kukunin natin yung sagot, so constant yung ating 75 for a dipole. Palagi kasi yan that the resistance at the feed point of a dipole is equals to 75 ohms all over sine squared of ang pi natin is constant, multiply mo sa diameter which is 0.25 all over ano yung lambda. So take note that the lambda is equals to C over F. So what is your F? Given naman yung frequency that is 300 megahertz. So 3 times 10 to the 8 all over 300 times 10 to the 6. So that is 1. Tama ba? 1 meter. So divide mo ito ng 1 meter. So the radiation resistance is roughly 150 ohms. Paki-check. If 75 all over sine squared, quantity pi times 0.25 over 1 is 150 ohms. Tama ba? Parang ibig na sabihin yan, dodoblin yung sine of pi times 0.25 times sine 0.25 pi. Parang gano'n lang. So make sure that your calculator in radian mode kasi naka-pi kayo. Make sure your calculator in radian mode. Tama ba?
Yes po, sir.
Okay, 150 ohms. How about sa iba? Nakuha niyo 150 ohms?
Yes,
Okay,
sir.
another. Number 3, calculate the radiation resistance of a halfway dipole that is 0.1 meter from the end of 300 megahertz. So, ganun pa rin yung formula natin. So the radiation resistance is equals to 75 all over sine squared of pi times 0.1 all over 1 na lang din kasi magkamukha naman siya ng frequency. 300 megahertz, so that is 1 meter. So is it correct na it is equals to 785.4 ohms? Paki-check. So again, your calculator must be in radian mode. Okay, so nasusundan ba? Okay, next. So what is the length in feet of one half wavelength of coax with the velocity factor of 0.63 at 28 megahertz? So ano daw yung length in feet ng half wavelength? So ibig sabihin, half wavelength is lambda over 2. Okay. So what would be the actual length if the velocity factor, so given din yung velocity factor natin na 0.63 with the frequency of 28 megahertz. Okay, so kailangan nyo muna kunin yung velocity of propagation, di ba? Kasi binigay yung velocity factor that the velocity of propagation will be equals to velocity factor multiplied by the speed of light. So since given yung velocity factor mo na 0.63, we're going to multiply it by the speed of light, that is 3 times 10 to the 8 meter per second. So what would be the velocity of propagation? That is 0.63 of 3 times 10 to the 8 meter per second. Ilan? 2.4? 2.4 ano? Oh, yan ano. Yan na? 189. Sure ka ba? 1.89 times 10, di sila sumagot. To the 8. Wala? Ba't to 6? Eh, ito nga, pag ginano mo yan, 189 meter per second. Then, kung kukunin mo yung wavelength, the wavelength is equals to ilan? Velocity of propagation, not the C, kasi binigay yung velocity factor eh. So, instead of C, velocity of propagation all over the frequency. So, that is 1.89 times 10 to the 8 all over 28 times 10 to the 6. So, what is the wavelength? Ilan? 6.75. Wala nang sumasagot sa ano? Sa Lago Online. $6.75 at is the unit. Meters yan. Now, ang tinatanong is the half wave dipole. So ito yung tinatanong. Therefore, yung 6.75 meter, divide mo ng 2. So that will be the lambda over 2. Ilan? 6.75 divide 2. 3.375. Meters. Ang sagot. Eh, in feet daw. So note that for every 1 meter, that is 3.28 feet. Tandaan niyo yan, ha? So that is for every 1 meter, there is 3.28 feet. So ilan ang sagot?
11.7.
11.07.
07.
7. 11.7?
07.
07 po.
Putol-putol yung yung online. Okay, so that would be your answer. Eh, paano ko sinabi? What would be the actual length of the half quarter wavelength? So, quarter wavelength is lambda over 4 ang gagamitin. Eh, paano pag sinabi? What would be the wavelength of a Hertzian dipole? Hertzian dipole, lambda over 10. Alam, huwag na kaya tayo magklase. Ha? Naiintindihan ba?
Yes, sir. Naintindihan
Dapat
po.
tayo sumagot. Pagka alam sumagot sa susunod, kanya-kanya na lang solve ito, ha? Okay, next. So what is the actual length? Ito na nga, of a half-quarter wavelength coaxial cable with a velocity factor. So same lang din. Given ang velocity factor that is equals to 0.695. And the frequency is given by 42 megahertz. Again, kunin nyo yung velocity of propagation, that is velocity factor multiplied by the speed of light. So velocity of propagation will be equals to 0.695 times 3 times 10 to the 8. Ilan ang velocity of propagation? Ilan?
2.085 po.
2.085 times 10 to the 8
8 po.
meter per second. Now, kung kukunin mo yung lambda, so that will be velocity of propagation over frequency. Since wala tayong speed of light, ginawa na nga natin velocity of propagation. So the lambda therefore will be 2.085 times 10 to the 8 all over the frequency of 42 megahertz. So 42 times 10 to the 6. So ilan?
4.96 po.
4.96. 4.96 meter. Now, ang tinasabi ay quarter wavelength. Therefore, the quarter wavelength lambda over 4 is equals to 4.96 meter divided 4.
1.24 po.
24 meter. Mali pa yan. Okay, ayun na. Ano tayo klase? Alam nyo na to. Centered at 174 meters. Calculate the driven element, reflector, and director. Okay, so sa Yagi Uda. So ano ba yung frequency na binigay? So that will be 174 megahertz. So mo yung lambda. So that will be C over F. So hindi mo na gagamitin yung velocity factor. Ang binigay na hindi mo na gagamitin yung velocity of propagation since wala namang velocity factor. Velocity of propagation is speed of light. So C over F na yun. So lambda will be equals to 3 times 10 to the 8 all over frequency of 174 times 10 to the 6. What is your
1.72.
lambda? 1.72 meters. Now, Yagi Uda yon. So ano yung pinapatanong? Calculate the driven. Sabi natin sa Yagi Uda, the driven element DE is equals to dipole lang, lambda over 2. Okay? Yung directors is equals to ilan? Ang directors ay mas mababa ng 5% sa driven element. So, ibig sabihin nun, 0.95 of lambda over 2. Then, yung reflector will be 5% greater than sa driven element. And therefore, 1.05 of lambda over 2. Okay? So, binigay ba yung sinasabing end effect? Hindi naman. O normal lang ang computation mo. E paano kung wala sa calculation? Consider mo end effect. Multiply mo pa siya yung answer. Lambda mo, that is lambda of 1.72. So therefore, the driven element mo will be equals to 1.72 meters. Divide mo lang ito. Ilan? 0.86 meters. So that will be your answer. So the director is equals to 0.95 of 86. Ilan? 0.817 meters. Yun. Then the reflector, mas malaki siya. So that is 1.05 o 0.86. At siguro, ano na yan? 0.86 o 0.903. So that would be your okay? So palagi tatandaan that the rector is greater than the driven element by 5%. Okay? Kuha. Intindihan ba?
Yes po.
Okay, next. Calculate the gain of helical antenna. Tatandaan nyo rin yung formula for helical antenna. Okay. Okay, meron tayong gain beamwidth, no? So, gain muna. Gain is equals to 15. Ito. Yan, note ko kanina yan. Saan na ba yun? Ayun. 15 NS. 15. Iba-iba kasi ng formula to, no? 15 NS pi d squared over lambda cube. Sa ibang book, iba yan. So, kung ano yung ma-memorize nyo, pwede na yun. Basta kailangan meron kasing 15 NS pi d over lambda squared of pwede nyo. Para kung ayaw mong mag-memorize ng gano'n, yung buong na memorize mo, ito na. Then the beam width is equals to another formula sa book yan. Pero meron din sa formula na 52 lambda over pi d. Square root of lambda over NS. Sa ibang book, sasabihin nyo, sir, iba naman yung pinamemorize nyo. Same din yon. Pag sinimplify nyo, same din yung lalabas doon. Yung iba kong na-memorize dyan is 52 over lambda, NS over lambda, may ganun-ganon. So, bahala kayo. So, ito, naka-dB na yan, and ito, naka-degrees. Okay, now, ano yung N, ano yung S, ano yung D, at saka lambda. So, halimbawa, meron tayong helical antenna, ganyan. So, sinabi dito that the helical antenna diameter. So, binigay yung diameter. Ayun, no? Diameter daw ay, ang diameter niya ay 80 millimeter. Kailangan niya naka-meter. So, that is 1, 2, 3, 0.08. Ano ba? 0.08 meter. And then, binigay din yung pitch. Yung pitch, yun yung spacing between, ano? So, ito yon. Ito yung pitch natin, that will be the spacing. So the spacing is around 62.5 millimeter. So that will be equals to 0.0625 meters. And meron kang 8 turn. Walo. So 8 daw, binigay naman, no? And operate at 1.2. So the frequency is binigay, that is 1.2 gigahertz. So your lambda therefore is ilan? 3 times 10 to the 8 all over 1.2 times 10 to the 9. So what is your lambda? 0.25. Tama ba? Okay, 0.25 meters. Now, so yung lambda mo ay 0.25 meters. So therefore, using the formula, yung gain, ako-compute nyo na. 15 multiplied by 8 multiplied by 0.0625 all over 0.25 multiplied pa ito ng pi d over lambda. So that is, ano ba yung d natin? 0.08 pi square. So ilan yung gain mo dyan? What is 50 times 8 times 0.0625 times 0.08 pi lambda, pi square, all over 0.25 cube. So, naka-TV na yan. Ano nakuha nyo? Nakuyang. 15 times 8 times 0.0605. Ano? Ano nakuha nyo? Iba? Ano? 30.31?
Yes po, sir. 30.
Yes po,
Ayun.
sir.
Ibig sabihin, di mali itong sagot. Ano lang yun? 30.31 dB. Okay? 30.31 dB. Okay? Ay. How about your beam width? Ilagay nyo lang din sa formula. Beam width is equals to, yung formula natin, 52 times 0.25 all over 0.08 pi multiplied by the square root 0.25 all over 8 multiplied by 0.0625. Ilan ang beam width? Iba din siguro yan. Kasi baka namali ako lagay. 36. 36.6. O, yun, tama pala. Baka isa lang yan. Okay, so ibig sabihin nun, sa formula lang. So sa board examination namin, nung binigay yan, helical antenna. Ewan ko lang sa board examination yung magbibigay. So, pero mayroong ibang formula dyan, no? So, maaring hindi ganito, pero pag kinumpit ko, same lang din. Nasundan? Nasundan ba?
Yes po, sir.
Okay, number
Yes
8.
po, sir.
So, calculate the directive gain and beam width between two nulls of a paraboloidal reflector antenna with a mouth diameter of 2 points. Okay, tatandaan, no? Kapag ang illumination efficiency mo is around 0.55 to 0.6, automatically that the beam width is equals to 70 lambda over d. Palagi yan, tandaan nyo to, ha? So that is the beam width, okay, of a parabolic antenna. Now, binigay naman yung diameter, 2.4. Yung illumination efficiency, binigay naman yan, automatically pag ang illumination efficiency is 0.55 to 0.6, 70 lambda over d na agad. Now, yung frequency mo, binigay na 6 gig. So, can we now the wave? So, 3 times 10 to the 8, 0.05 meters. So, gamitin nyo na. So, yung beam width mo, 70 lambda over d. So, the beam width is equals to 70 lambda, which is 0.05, over diameter, binigay naman na 2.4. 2.4. Ilan? Ilan ba? 1.46
1.46.
degrees.
1.46.
1.46 o 1.44?
46 po.
46 po.
Now, ang sinabi kasi dito, calculate the beam width between two nulls. Ayan, may nakalagay na between nulls. Pag sinabing between nulls, ang hinahanap mo ay hindi beam width alone. So, hindi beam width between two nulls will be equals to 2 times the beam width. Kasi, yung ating beam width, let's say for example, I have here a tawag dito, the radiation footprint. So, sinabi natin, di ba, ito yung ating 3 dB point. Yan. Ito, yung center line mo. So, ito ay tinatawag natin na beam width. So, ito yung tinatawag natin na beam width between two nulls. Okay. Kaya, since symmetrical naman yan, so the value of the beam width between two nulls will be twice of the beam width na makukuha mo. So the answer therefore will be twice of 1.46 degrees. Ilan ang beam width between two nulls? 2.92 degrees. So yun yung correct
92.
answer. Kaya tingnan nyo mabuti kung ang tanong ay beam width or beam width between two nulls or between nulls. Parabolic will be 7.5 plus 20 log of therefore will be 5. 7.5 na. O sige, tama yan. 7.5. Basta pagkakaalala ko. 7.5 plus 20 log 6 gigahertz. Naka-gigahertz yung 6. And then, plus 20 log of diameter 2.4. Okay? Ilan? 26. Kayo? 2.4. Ilan?
30.67 sa akin, sir.
67.
67.
B.
So that will be your answer. Tignan nga natin. Mali yata yung nakuha ko sagot. Ay, ba't gano'n? 41. Hindi, first tama yan. Sige. Mali, baka, kasi baka ako nang nalalagay. Pero, yan yung tamang formula. Yan yung tamang sagot. 20 log. Yung nga may formula. Teka. 20 log of every gigahertz. Log of sin. O, tama yan. Ganyan, 7.5 or minus 7.5. Hindi, pagka minus yan, ano. Sige, yan na nga, tama yan. Okay, mali pala. Okay, mali. Yung ganung formula, so this diameter must be in feet. Naka-feet yan. So, mali. Barahin natin. Kasi, yung ganitong formula, the diameter should be in feet. Therefore, convert mo muna yung 2.4, convert the 2.4 meter into feet. So, for every 1 meter, there is 3.28 feet. Ilan? 3.28 times 2.4. 7.87 feet. So, ilalagay mo doon, 7.87 feet. Okay, so ito ay 7.87. So, siguro tama na yan. Gain in dB must be 41. Ayun, perfect. 41 dB. Answer. Okay, so make sure na tingnan niyo yung mga parameters, no? Kasi yung pagka ano to, ay pagka ginawa niyong meter ito, mamaya siya yata ng 14.0 something. Basta gamit. Ayan na lang gawin niyo, 41 dB. Okay, next. Number 9. So number 9, to minimize the interference, a 500 MHz dish need to have a 1 degree beam width. What diameter required in wavelength and in meters? Okay, may frequency ka, number 9. Ang frequency mo, 500 megahertz. Ngayon, the beam width required is 1 degrees. Ano ba sinabi ng antena? Ang sabi ay dish. Ibig sabihin, parabolic dish siguro. So, ano diameter in meters and in wavelength? Okay, so, kadali lang. So, meron kang beam width that is equals to lambda over d. Parabolic dish. Then get the lambda will be 3 times 10 to the 8 all over 500 times 10 to the 6. Ilan yung lambda mo? Times 10 to the 6. 0.6 meter. So using this formula, so the diameter will be equals to 70 lambda over the beam width. So the diameter in meter must be 70 of 0.6 over 1. Diameter sila. Ha? 42? 42 meters. So ganun kalaki yung antena mo, 42 meters. Okay, ito yung mga ginagamit sa mga cosmic satellite. Yun, 42 meters. Okay, yung malalaki yan para ginagamit sa mga cosmic radiation. Okay, number 10. Okay, so what is the active radiated? So pre, ito na yung pre patay gutom. Pre-PG. Kaso, ang tinatanong dyan, what is the effective radiated power or the ERP of a repeater with 450 watts transmitting power output with 4 dB feed line loss, 6 dB duplexer loss, 7 dB circulator loss, and the feed line antenna gain of 25 dB. So, ibig sabihin, yung ERP. So, number 10, sa number 10, ano ba yung ERP? Nasaan yun? So, di ba ito yung ating transmitter antenna? Yan. So, andito yon. The PT, lalabas siya sa transmitter natin. Ito, transmission line, magkakaroon ka ng mga loss. So, ilan yung loss mo dyan? So, the total loss will be, ano ba yung sinabi na loss? Ang sinabi na loss ay, feed line loss, pinaka-transmission line loss mo, 4 dB, duplexer loss, 6 dB, circulator loss, 25, babali 4 plus 7. Okay, so 4 plus 6 plus 7 dB. So 17 dB yung loss mo. Ngayon, may transmitter power ka daw. Dito, ang transmitter power mo, lalabas dyan, PT, is equals to ilan? 450 watts ba? 450. Yung antenna mo, 25. 450. So, yung antenna gain mo is 25 dB. Ano ba yung ERP? Yung lilitaw dito. So, pag lumitaw na dyan yan, so that will be the ERP. The ERP is given by PTG. In antenna, yun na yun. Kaso, paano mong maima-minus ito watts na may loss ka na naka-dB? What you're going to do, you make this dB watt. Paano gagawin yon? 10 log 450 watts, di ba? So, the PT, therefore, is ilan? 10 log 450? 26.53. 26.53 dB. Nakuha ba yun? Gagawin natin dB watt para i-minus-minus na lang natin. So, the ERP, yan yung makuha mo. Or, pwede din namang yung ERP mo will be PT na naka-dB plus 8 na naka-dB. So, ang lilitaw mo dito, dB watt. Yan yung pinakamadalis. So, therefore, the ERP is equals to 26.53 dB watt minus, kasi loss, total loss mo 17 dB plus, bakit plus? Gain kasi yan antenna, 25 dB. Can we add dB watt and dB? Oo. O, ilan yan? 26.53. Siguro balloon siya, nagsasalta mag-isa. 26.53 minus 17 plus 25 lang. 36.56 dB watt. Ah? Ano? Ay, ba't iba-iba yung buto? May nagkakatayan yata. Ano talaga?
34.53 po.
34.
34.53. 53.
Opo,
Now,
sir.
ang ERP tinatanong naka-watts, o you need to convert that into watts. Therefore, paano kukunin yon? So, 34.53 is equals to 10 log ERP. The ERP is equals to inverse log of 34.53 divided 10. Divide 10. Tapos shift log. Ilan? Ilan? Tama? Malaki nga yan. Lalaki yan. 2877? 2837 o 38 watts. So, yun yung effective radiated power. Ito, 830. Okay? Ayun. So, another solution dyan, ang gagawin nyo, convert mo, or kung gusto nyo, gamitin nyo yung PTG na to, gamitin nyo yan, but you need to convert the losses and the gain. So, ang loss natin, ang total gain natin will be loss minus A. Ilan? Gain in dB. So, 17. Ay, ilan na yan? 17. 5. So, ilan? Negative 8 dB. O, convert mo yan sa unitless. So, gain dB. So, gain unitless will be inverse log of negative 0.8. Kasi 8 over 10 yan. Ilan? Ilan? Inverse log of negative 0.8. Or 0.8 lang. Yan. 6.33. O, times mo ng 450. So, shift log. Positive mo lang. 6.31. O ngayon, yung ERP mo, ERP, di ba, PDB? So that would be multiplied to 838 watts or malapit. O, di ba ganun? So they are almost the same. Kung anong gusto mo, bahala ka. Sa tama sa ganun din, pwedeng yung ganun na, yung gusto yung PTG o yung pero pinakamadali na itong minus-minus na loss na ito. Pinakamadali. Then convert na lang sa final answer. Okay na siguro yan? Okay, so helical antenna with the following. Ano na lang din, gamitin nyo yun. Yung formula kanina. So ito yung ating S. Paki-ano na lang. Ito yung ating S. Ito yung ating D. Ito yung ating N. Ayun. So, makuha nyo ba yung 19 dB? Get nyo na yun. Hello, nasusundan pa ba?
Opo, sir.
Yan. Okay na, gumawa ng 11 na. Number 12. What is the electric field intensity? Or EFI yun. EFI. So sabi natin, number 12, the electric field intensity is equals to square root of 30 PT over R. Okay. Yan yung formula. Okay, so meron kang R. Ito na yung R mo. Dahil kailangan niya naka-meters ito. Then ito naka-watts. So meron kang half-wave dipole. Yan. Meron kang antena na half-wave dipole. Ano yung gain ng half-wave dipole? So get mo muna yung ERP nun. So PTG pa rin. Ano yung gain ng dipole? Half-wave? 1.5 ba? Tama ba? 1.5 o 1.64? 1.64 o 1.75? Ayan, 1.5 siguro. 10 log 1.5. Ayan, tama. 1.5. So, ang gain ng dipole, half wave kasi. Okay. So, yung gain niya is equals to 1.76 or 1.5 dB. Half wave dipole. Eh, binigay yung transmitter power mo na 15 watts. So, meron kang ERP doon. So, yun yung ilalagay mong PT doon. Actually, yung PT na yun, yung ERP mo. Ayan. So, yung PT mo na yon, i-express mo siya sa ERP. Kasi hindi naman siya directly galing sa transmitter. So, meron ka pang antena. So, the ERP is PTG. Given naman yung 1.76 yung gain yan, sinabi sa inyo nakaraan. So, the ERP therefore is equals to 1.76 of 15 watts. Ilan? 26.4 watts.
26.4.
Now, kung gagamitin natin yung formula that the electric field intensity is square root of 30 PT is equivalent to ERP since half-wave dipole, multiply mo siya ng 26.4 all over radius. Ang radius ay ilan? 10 kilometers. So what is 10 kilometers in meters? So that is 10,000 meters. Again na yun. So the unit is volts per meter. Ilan? Yung taas lang ang naka-square root. Ayun. So dito is 2.81, 2.72. Pwede na yan. 2.81 millivolts per meter. Times 10 negative 3. Ayun. Kaya millivolts per meter. So almost tama na yan. 2.73 at 2.81. Tama na yan. Okay. Next. Number 13. So calculate the power density. Efficiency of half-wave dipole to silicon. Okay, ganun din. Yung power density mo naman, power density is equals to PT over 4 pi r square. So since meron ka na namang half-wave dipole, you need to convert that PT into an ERP. Okay? ERP is equals to PTG. Okay, so the ERP therefore is equals to half wave na naman, no? Eh kaso 90% efficient lang siya. So meron siyang efficiency na binigay that is equals to 0.9. So yung half wave dipole mo, ilan? 198 watts. Yan. Tama ba? 198 watts? Oh, 198. Therefore, the power density, PT, 190, na ERP na ilalagay natin na 198 over 4 pi multiplied by radius square. Ilan yon? Saan siya nakalagay? 25 kilometers. Then square mo pa yon. So the unit will be watts per square meter. Ayun ba yun? 2.52 times 10 to the negative 8 watt per square meter. Tingnan natin kung tama.
8.
Pag dinasog mo yon, yun din yun. Pero parang 2 point, kaya mo na, may error naman na. Ayun na yan. Okay. 14. So, the efficiency of antenna is 82%. The radiation resistance is, ilan yan? 30. 30 ba yan? Hindi ko makita.
30. Kapong 30.
Sige, 30 daw. So, R rad is 30 ohms. So, efficiency is equals to 82% or 0.82. Tinatanong is the loss resistance. So, tandaan natin, efficiency is equals to R rad over R rad plus R ohmic resistance times 100. Okay? So, since 82 siya, so 82 equals, ang radiation resistance mo 30 over 30 plus RO times 100. So, ilan na makukuha nyo? Chip solve. So, RO will be equals to ilan? Huh? Chip solve, 97. Ayun. 0.82 na lang kasi di-divide sa 100 yan eh. 0.82 6 point. Ilan nakuha? 6 point. O yun, 6.58 daw ohms. 6.59 yung sagot to. Tama yan. Yan na yan. Okay, number 15. A power density of 1.57 times 10 to the negative fourth is measured 50 meters from the antenna test with the gain of dito. So, ang power density mo is equals to ERP over 4 pi R square, di ba? So, yung power density binigay siya na 1.57. So, this is number 15, no? 1.57 times 10 to the negative 4 watts per square meter. Ngayon, ang layo niya, 50 meters daw. Ngayon, may gain yung antenna yan. You need to convert the gain mo na na G. So, yung 2.15 dB, you need to convert that to unit test. I think that is 1.76. Equivalent siya sa 1.76. Ano nga? Inverse log of 0.215. Inverse log of 0.215. 1 point? Oh, sige, 1.64. Equivalent siya sa 1.64. Yan, na unitless. Now, ilan daw yung power na nilagay sa antena? Edi yun yung PT mo. RP is PTG, therefore, yung 1.5 times 4 is equal siya sa G, which is 1.64. 4 pi multiplied by 50 square. Chip solve. Ang gawin nyo na lang, 1.57 times 10 negative 4 times 4 pi times 50 squared, divide mo na 1.6. Ilan? 3. 3 watts. Okay, so 3 watts yung ayun, 3 watts. Okay, so 3 watts, kapag lumayo siya ng 50 meters, the power density is equal to 1.57 times 10 to the negative 4. Ano pa? Number 16. So number 16, determine the radio horizon for antenna 200 meter high and receive antenna. Then yung radio horizon mo D will be square root of 2HT in feet plus 2HT HR in feet. Okay, square root din yan. So the unit mo dyan will be miles. Okay? So ang unit mo pag ganung formula, miles. Or, pwede din namang D will be square root of 17 HT in meter plus square root of 17 HR in meter, naka-kilometer na yon. So since ang hinahanap ay naka-meter siya, ito gagamitin yung formula. So the radio horizon distance will be square root of 17 times 200 plus square root of 17 times 100. Yung naka-kilometer na lang. Ilan? Ang radio horizon distance mo. 100 daw sagot. Ilan? $101 kilometer or roughly 100 kilometers ang maabot. Okay? Susundan. Ayan. Number 17. So number 17, how much two antennas should be separated for a space diversity of 11 GHz band? So, halimbawa meron kayong microwave antenna. So, halimbawa meron na antenna 1 din antenna 2. So, there must be a separation. Separation, pwede kang gumamit ng 3 lambda RE over D. So where RE is the effective radius of the Earth, that will the K factor RO. Where RO is the true radius of the Earth, that is 6,370 kilometers. So kung hindi naman bigay yung K factor, hindi mo na makukuha. So it can be 2/3, 4/3, or infinite. So usually ito ginagamit natin. Since wala namang binigay na ganon, so hindi mo gagamitin ito. Ano ba binigay? Kasi 11 frequency ang bigay. Namang effect yung distance of transmission between two tower, pwede mong gawin yung 3 lambda RE. This is called multiple of lambda space separation, space diversity separation. So since ang ay frequency, you can use or roughly 200 lambda. So yan ang gamitin nyo. P over F. So ito na yung gamitin nyo. So you can use this one given yung mga another formula na yan. So you can use this two second formula kung ibigay lang yung frequency. So 3 times 10 to the 8 all over 11 times 10 to the 9. Giga, 9. Ilan?
0.027.
Ilan? 0.027. 0.027 meters. So therefore, the space separation will be 200 of 0.07. Yan yung separation ng antenna mo para ma-isolate. Ayun, 5.45 meters. So, ito. Nakuha nyo sagot na. Okay, 5.4. Pwede na yan. Okay, nasusundan ba? Laki na kayo, alam nyo na yan. 18. So, the dipole antenna has a radiation resistance of 60 ohms. So, kanina efficiency is equals to R rad over R rad plus R of times 100. So, the efficiency therefore will be 67 all over 67 plus 5 times 100. Answer. Oo ah. Wala na sumasagot eh. Alagay tulog mo.
Si Derek po, sir. Si Frederick, sir. Si Derek.
Sir, delay po kasi.
Estada, anong sagot? Delay daw ako. Anong number pa lang ba ako ngayon sa inyo?
Sir, mahina po talaga yung internet dito. Mahina talaga. Kahit kanina.
Tigil na kayo natin
Kaya
ito.
wala po kayo nausap.
Okay, game na. Last na yon, 80 na yon, 20. 19. Calculate the field strength of a Hertzian dipole. Pagka Hertzian dipole, yung EFI mo, yung field strength kasi kanina, that is square root of 30 PT over R volts per meter. Yan, kung general antenna. Paano kung specific antenna? Paano kung specific? Yan yung sa general. Pag specific at sinabing Hertzian dipole, so may formula yan na 60 pi Li over lambda R times sine theta. Okay, so kasi yan ay mga radiator lang. So 60 pi Li lambda R times sine theta. So ano yung L? That is the length. So which is, nasa length mo dito. Ayun, 2.5. Then I will be the current. Ayun yung current. Then frequency, lambda, ayun, makuha mo dito yung frequency mo. Then the distance, ayun yung R. Then yung theta, yun yung theta mo. So, given na. Pag Hertzian dipole, tandaan nyo yung formula na to na field strength. So, therefore, the field strength is equals to pi multiplied by 2.5 multiplied by 1.2 all over, kunin mo muna yung lambda, that is 3 times 10 to the 8 all over 1 meg. Ilan? 30? Parang 300 meters ba? Ano ba yan? The exponent 8 divide 1 is 300 meters. So yung wavelength mo. So 300 multiplied by ano kalayo? 500 meters. Sine of 30 degrees. So your calculator nyo dyan, naka-degree mode. So what is the field strength? Ang unit yan, volts per meter. Siguro 1.88 yan. Times 10 to the negative 3 volts per meter. So that will be the EFI. Diyan ay kung binigay yung specific Hertzian dipole, ano. Pagka half wave yan, ay lang ko, 120 pa yata yun. Hindi ako nagkakamali. Pero kung general na EFI, square root of 30 PT over R lang. Okay? Next. Last number. What would be the ERP? Having a field gain of 3 and the input power of 1 kilowatts. So, yung ERP natin, kanina pa natin binabanggit, PTG. PTG. Kaso, this is the power gain. Ang binigay kasi hindi power gain, kundi field gain. So, the ERP is equals to PT, okay, field gain. So, that will be GF. Pagka field gain, ini-square yun. Okay? Kung hindi nyo square yon, ang ibig sabihin, ang ginawa nyo ay power gain. E malinaw naman sa problem na field gain. Therefore, the ERP will be 1 kilowatt multiplied by 3 square. Kasi field gain ang binigay. So the answer will be 9 kilowatt. So dyan maraming namamali. Kala nila ang formula lang ay PTG. That's correct if it is power gain or gain. Pero in-specify kasi dito that is a field gain and therefore you should square it before multiplying to the transmitted power. Okay? So hanggang dito na lang yung ating lesson. So siguro meron ito sa exam. Okay, summary. Okay na yan?
Yun nga yung inaabangan.
Oo. So, yun na itong nakaraan. Inulit ko lang yan. Okay, so wala na. Hindi na intindihan.